Hello and welcome everyone. Today we have like previous videos we have already seen the reaction of metal with air we have seen, with oxygen, reaction of metals with water we have seen, reaction of non-metals with water and oxygen, everything we have seen. Today we are going to talk about reaction of metals with acid. So in this, when metals react with acid, it's not that every time we will get the same thing. Okay, in general, when metals react with acid, salt is formed plus hydrogen gas is released. Okay, in general, when metals react with acid, we get salt and hydrogen gas is released. But again, different acids will, when react with same metal, we will get, different acids when react with with same acid, we will get differently. Differently they will react. Similarly, different acids when react with same metal, their reaction will be quite different. It's not that every time we will get the same thing, or every time all the metals will react with the same acid. Okay, so now we will see the reaction of metal with dilute hydrochloric acid. We will see this. Okay, here when we will see, this is the reactivity series. In previous videos, what we have seen, as we go down, the reactivity increases, and the more reactive metals react with water or with oxygen vigorously. But when the metals react with acid, it's completely different. Okay, now we'll see how. Like suppose first we will take Mg, magnesium. When magnesium reacts with dilute hydrochloric acid, what will we get? We will get MgCl2 plus H2 gas. Okay, and we will quickly balance it. So this is the balanced equation. This is magnesium, this is hydrochloric acid, which is in a dilute form. We are getting magnesium chloride salt and water. Now, magnesium, it is highly reactive. Okay, this is highly reactive metal. When this magnesium reacts with hydrochloric acid, we get magnesium chloride salt and hydrogen. But when we talk about copper, copper doesn't react with dilute hydrochloric acid at all. Okay, copper doesn't react with dilute hydrochloric acid. So that's why we can say that different metals react with acids differently, or you can say same acids can react with different metals differently. So this is one type of metal which when reacts with acid, we get salt and hydrogen gases evolved. Now we will talk about another acid, that is aqua regia. Aqua regia. This is a very interesting type of acid, aqua regia. Why it is interesting? This is actually, what is aqua regia? First we will see. Aqua means watery. Okay, so this aqua regia is called as a royal water. Aqua regia is called royal water. And how is aqua regia formed? It is formed by the combination of two acids. This aqua regia is formed by the combination of concentrated hydrochloric acid and concentrated nitric acid. Okay, isn't it interesting that aqua regia is an acid which is a freshly prepared acid. Okay, it's a freshly prepared acid by the combination of concentrated hydrochloric acid and concentrated nitric acid. And it is very corrosive in nature. Okay, it is very corrosive in nature. And the very interesting part is it can dissolve. It can even dissolve gold and platinum. In our previous videos, we have already seen that gold is such type of metal which do not react with oxygen and also doesn't react with water. But aqua regia is a kind of acid which can even dissolve gold and platinum. Okay, now quickly we will see how gold reacts with aqua regia. Au plus HCl plus HNO3, because aqua regia is made by the combination of these two acids, gives us AuCl4 plus NO2 plus H3O plus H2O. So quickly when we will balance it, it will be 4, this will be 3, this will be 3 and 2. So this is 3, 7, 5, 6, 7, and this is, yes, I think this is a balanced equation. N is 3, O is 6, 7, 8, 9, 3, 3, 9. Yes, this is the balanced equation. This is Au is gold plus concentrated hydrochloric acid, concentrated nitric acid. This gives gold chloride plus this is nitrogen dioxide, H3O plus water. So this is the thing we get when gold reacts with aqua regia. Have you ever seen when your mother must be having gold ornaments? When it becomes very old, like 40-50 years old of the ornaments, generally what we do, we prefer to get it polished. So we take it to the jewelry shop. There in the jewelry shop, the person, what he used to do, he used to put that ornament in the aqua regia solution. Okay, and what is the function of this aqua regia? It dissolves the upper layer of the gold ornament and the upper layer is taken off. So the inner part or the lower part of the ornament comes out with the same shine as a new one. And so like this we get our ornaments polished. And if you will observe it nicely and clearly, what you will find? You will find the weight of the ornament after it is polished, it becomes slightly less. So this is how how gold reacts in aqua regia. And same is the process with platinum also, is the same process. Okay, so today we in this session what we have seen, how metals react with acid, and when metals react with acid we get salt and hydrogen gases evolve. Fine. Now we will see take another acid. The next acid we will take is, that is nitric acid. Now we will see how metals, when react with nitric acid, what we get. Okay, so nitric acid is a strong oxidizing agent. Okay, this nitric acid is a strong oxidizing agent. So here nitric acid is a strong oxidizing agent. What this nitric acid do? This nitric acid oxidizes hydrogen, that is H2 produced, to H2O, that is water, and itself get reduced to any of the nitrogen oxides. Nitrogen oxides means it can be N2O, NO or NO2. Okay. Yes. So nitric acid, they are so strong in oxidizing agent that it oxidizes hydrogen produced to water. Okay, and itself get reduced to any of the nitrogen oxide, maybe it's N2O, NO or NO2. Okay, so here we will see some of the reactions when metals react with nitric acid. So let's take magnesium only, some reactions. So here Mg, magnesium, when reacts with nitric acid. So first we will see the metals when react with dilute HNO3. Okay, first we will see metals react with dilute HNO3, that is dilute nitric acid. Suppose Mg plus HNO3 gives us MgNO3 whole 2 plus H2 gas. Okay, there just now what I said, that it is such an oxidizing agent, such a strong oxidizing agent, that it oxidizes hydrogen produced to water, to H2O. Okay, but then you will ask me why H2O is not formed here, because here we are taking a dilute nitric acid. That's why we got magnesium plus dilute nitric acid gives us MgNO3 whole 2 plus H2. Okay. Now second one, when metal, or directly I will write reaction with, this is first one, this is second one. Reaction with moderate, you can say, moderate HNO3. What is the meaning of moderate NHO3? Means how when metal will react with moderate NHO3. Dilute means you know. Okay. Moderate means it's not dilute, it's not concentrated. It should have an intermediate phase. Okay. It's not dilute, it's not that concentrated. So in this, when magnesium will react with HNO3, here HNO3 is moderate, we will get MgNO3 whole 2 plus NO2 NO plus H2O. Okay, we are getting the same salt here, but we are getting nitrogen oxide here because this is not dilute. Little concentration will be there. It's not very concentrated but not dilute. So as the later on we will see as the concentration keeps on increasing, the reaction between the metals with the nitric acid, which is a strong oxidizing agent, different oxides of nitrogen is obtained. Okay, so quickly we will balance it. This is 2, so if I write 2 here, this is 4, so 4, this will write 2 here, N is 4, O is 12, so 6, 7, 8, 9, 10, here. Okay, H is 8, so here I will write 4, 4 to the 8, yes, so this is the balanced equation we got. Okay, so here when magnesium is reacting, we are getting the same salt plus nitrogen oxide plus water we are getting. Okay, now next is reaction with concentrated HNO3. Reaction with concentrated HNO3. Here Mg plus HNO3, which is concentrated, we will get MgNO3 2 plus NO2 plus H2O we will get. So quickly we will balance it. This is 2, so this will be 4. So this is a balanced equation. This is NO3. Okay, so here because this HNO3 nitric acid is concentrated, so we are getting nitrogen dioxide and water we are getting. So this is how metals react with HNO3. Okay, how metals react with HNO3. First we saw how metals, what happens when metal react with dilute hydrochloric acid, that is dilute HCl. Next we saw how metals react with dilute nitric acid, moderate nitric acid and then concentrated nitric acid. Okay, so now from this what we concluded, the overall conclusion, we saw that metals react differently with different metals. Okay, now we let's quickly see, like if we will take metals like magnesium and manganese. Okay, magnesium and manganese react with HCl also and dilute hydrochloric acid also, and they will react with with nitric acid also. Okay, we have seen this. But when we talk about copper, copper doesn't react with dilute nitric acid. Okay, copper doesn't react with dilute nitric acid, and which all other metals which doesn't react, we can name it as aluminium and zinc also. Aluminium and zinc, they do not react with HNO3 at all. They do not react with HNO3 at all. But this copper reacts with concentrated HNO3. Okay. Copper doesn't react with dilute HNO3, but with concentrated HNO3, it will react. Okay. When we talk about aluminium and zinc, they do not react with dilute nitric acid, and they don't react with dilute HNO3 also. But magnesium and manganese, they react with both, like they react with HCl also, and they react with HNO3 also. So as a whole, we can conclude that metals react with acids differently. Okay, same metal reacts with different acids differently, and same acids react with different metals differently. Okay, fine. Now next thing we will see how non-metals react with acids. So the thing is, generally non-metals do not react with acid. Even if they will react, under some special conditions they will react, but generally non-metals doesn't react with acids. Okay, non-metals doesn't react with acids at all. Now quickly we will see what happens when metals react with bases. We have already seen what happens when metals and non-metals react with acids. Okay, so now we will take metals reaction with bases. Okay, so like we have already seen how to distinguish acidic and basic nature with a simple method, that litmus paper test, right? But like seeing at any substance, how could you make out that it's a base? So like it should have it has a soapy texture, and the taste is bitter in taste. Okay, those are bases. So examples can be sodium hydroxide, calcium hydroxide, and soda, that is sodium carbonate. So these are bases. So generally what happens when metals react with base, we get salt and hydrogen gases evolved. Hydrogen gas is released. Okay. So let's see the reaction of metal. Suppose we will take zinc. So zinc, when reacts with sodium hydroxide, NaOH, okay, what is formed? Na2ZnO3 plus H2 gas is released. This is sodium zincate. This is sodium zincate. Okay, that is a salt. So when zinc reacts with sodium hydroxide, sodium zincate is formed and hydrogen gases evolved. here this is important for us, because whenever metals react with base, when we get hydrogen is released, yes, then we say that metal is reacting with a base. Okay, so this is important here. So sodium zincate is a salt. We will get salt and hydrogen gas. Now second thing we will see, second metal, aluminium when reacts with sodium hydroxide in presence of water. Okay, hydroxide in presence of water, we will get sodium aluminate. This is sodium aluminate. Sodium aluminate is also a salt plus hydrogen gases evolve. So this is important for us. So this is how what we get, what happens when metals react with base. Now when we talk about non-metals, till now what we have seen that when reaction is with metals react with acid, what we have seen, the role of non-metals doesn't react with acid at all. Okay, but here non-metals, when non-metals react with base, what happens? Reaction with bases. Here also when non-metals react with base, we get salt plus water. Okay, we get salt plus water. So here let's quickly see. But one thing, this non-metals do not react with base directly. Okay, the oxides of the non-metal reacts with the bases. This is a very important point, that when non-metals are reacting with bases, they do not react directly. The oxides of the non-metals react with the bases to get salt and water. So carbon dioxide when reacts with sodium hydroxide, we get sodium carbonate, we are getting, plus water. This is a salt. Okay. Then when carbon dioxide reacts with calcium hydroxide, we get calcium carbonate plus water we are getting. So these are the two very good examples of when metals react with base, we get salt and water. I hope these reactions are clear to you. Thank you.